This is a video on glycolysis. It was a subject that I struggled with in school, and I kind of put together this chart. It's not the most advanced way to look at glycolysis, but it is in-depth enough to give you a general overall feeling of the process and what's happening. You can see on the left side, you have your enzymes. I'm not going to go too much into what enzymes are and how they work in this video. That's for if you're wanting something that's more advanced, an advanced understanding of what's happening in glycolysis. Then you'll see the products. These are the changes. The glycolysis starts with glucose, and the end product is pyruvate, which is what you're eventually trying to get to, which you will see at the top and the bottom there. And then on the right side, I've got some structures there just to kind of give you an idea of what's occurring. And then final products is also there in the purple, and that's just letting you know what you'll be getting at the end of glycolysis. I'm actually going to write this out on paper. We're going to kind of go through it and explain what things are. Again, not in extreme depth, but enough to give a good understanding of what's occurring. This is at a undergraduate level of understanding for glycolysis. So if you're watching this from a high school biology course, this is probably going to be a bit more advanced than what you are learning, which I would encourage you to learn it and be ahead of the class. If you're looking for something that's more at the graduate level, you're going to want a lot more depth than what this will offer. And you'll be looking a lot more at the enzymes in the green there and what's actually occurring. I think what I'm going to do first is actually just give a brief understanding of what an enzyme is. It's going to be very brief, just so you can understand what those things are doing as glucose slowly changes to pyruvate. So we're going to go down here on this paper. An enzyme, different enzymes perform different functions. So enzymes. Okay. So an enzyme is a protein. Now, there's primary proteins, tertiary proteins, secondary proteins, and quaternary proteins. I'm not going to get into what each one of those are and what they do, but we'll just say that this is multiple protein strands here. So you have a massive protein structure. Now, all these lines, what these actually are would be amino acids, and they'll kind of fold and have different attractions in different areas. If you want to know how those attractions work, I really encourage you to get into chemical biology or biochemistry to understand those things. So with an enzyme, you're going to have what's called an active site. And that is where the product, well, I should say the substrate, the thing that you're trying to have changed, is going to enter into. So in this case, we're working with glucose. So we'll say that we have a glucose molecule here. Okay. So what the glucose molecule will do as the substrate is it will go into the active site. So it will take up this area here. There will be different types of amino acid structures on the inside of the active site that will cause changes in the substrate. Those changes are what will allow the product to undergo whatever change is necessary. So it might cause a certain part of it to become more positive in charge, and so something can be attracted to it. It might switch certain atoms around in the structure. It might split it in half. There's multiple things that different enzymes can do. So when we're looking at glycolysis, we're taking an examination of what each enzyme is doing to the product. Now, I'm only going to go over a few of the enzymes in glycolysis to explain what they actually do. I encourage you to get online and really look into the rest of them. We're definitely going to hit hexokinase because that is a very big one, not just in this, but any type of kinase is very crucial to all of biology. With that, we'll kind of get started here. So it's going to be, we're looking at glycolysis. Now, what is glycolysis. You probably already know that answer if you're looking at this, but glycolysis is the process of breaking down sugar, or in this case, glucose molecule. We're breaking down a molecule of glucose. So, glucose has its own structure. Let's see, sorry about that. Oh. Gonna make this really quick. Now, you'll notice certain things on here, like the OH. You have lots of OHs here. Sugars are actually comprised of a lot of OHs, and these are called hydroxyl groups. If you're not familiar with functional groups, hydroxyl is a functional group. That's another important thing that I would encourage you to take some time to learn. We're not going to actually be hitting that for this phase in this video. Okay, so this right here is your glucose. Glucose molecule. Okay. And over here, this, we're going to have this, not draw, but they're going to have this enzyme here. And this is hexokinase. Okay, now glucose is going to undergo a change to what we would call glucose 6-phosphate. Now I'm just going to put a P and circle it for phosphate so I don't have to write it out every single time. This is actually something that a lot of biochemists will do. Just shortens the process. Now this has to do with nomenclature and how things are named. It can be pretty complicated. It's an entire chapter in a book all by itself in a textbook. Essentially what this is saying is that you have glucose, and on the 6th carbon atom, you're going to have a phosphate group. Now, of course, you see in this structure, there is no phosphate, but that's what hexokinase is going to do. Hexo means 6. Okay, so you have 6 carbons here. 1, 2, 3, 4, 5, 6. That's an oxygen there, so you're not going to count that. Anytime you have an area, oh, I made a mistake here. This is actually supposed to be a line going off of this. So you'll actually have a carbon right here as well. So this is going to be your first one. So 1, 2, 3, 4, 5, 6. That's not right. Okay, let's try this again. So it's the 6th one. 1, 2, 3, 4, 5, 6. This is your 6th carbon right here. Sorry about that. Okay, so what a hexokinase is going to do is it's going to cause a phosphate group to attach to this hexo sugar. Okay, or in this case, the hexo sugar is a glucose. So where is this phosphate group going to come from? Well, that's where ATP comes into play. Okay, so we're just going to do this little loop here, and you'll see this a lot in textbooks. So you have an arrow like this. So ATP, adenosine triphosphate, that's your energy currency in your whole body. Everything you're doing in your body is using ATP. Every tiny possible thing, it is the expenditure, it is the money expenditure of the human body. So now this stands for adenosine diphosphate. Obviously, tri is 3 and di is 2. So the phosphate is coming off of the adenosine triphosphate, making it adenosine diphosphate. Hexokinase is having the responsibility as an enzyme to take that phosphate group and attach it to the glucose molecule. Now, with that phosphate group added, okay, now this, that's supposed to be an H there. With this phosphate group added, it becomes up here, and this is the chemical formula for the phosphate group when it becomes added, and it has a -2 charge. Now, in chemistry, we put the negative after the number, just so you're aware of that when you see that. You don't put it in the front. So then the product becomes glucose 6-phosphate. Okay, underline that there. Now we're going to go through another change. Now I'm going to put 2 arrows here. with a half, or excuse me, 2 lines with a half arrow on both sides. So what does that signify? You see up here that we have 1 arrow. That means that it's just going to be going from glucose straight to glucose 6-phosphate. With 2 lines, we're saying that the product, which in this case, we're going to be going to fructose 6-phosphate. And I'll explain what that is in a minute. What we're saying here is that this, with the enzyme that functions for it for its next change, which we're going to write that here right now, it is phosphoglucose isomerase. Okay. You'll notice that, sorry, I'm going to hit on this really quick, then I'll get back to that. You'll notice that different enzymes kind of have a different name to it. Like this is a kinase, this is an isomerase, you'll see a mutase in here. Those names kind of give you an idea of what that function is going to be. So when you have a kinase, you're going to be working with phosphorylation. You're going to be adding a phosphate group. When you have an isomerase, you're actually going to be switching the structure, and I'll show you how that structure change occurs here. But first, let me touch on these lines again. So when you have glucose and then you're connecting to a single line, essentially you're saying that glucose is only going to go to glucose 6-phosphate. Now when you have 2 lines, glucose 6-phosphate can change to fructose 6-phosphate, but it can also change back to glucose 6-phosphate. So the reaction can occur product to reactants. It can go back and forth. Okay, and a lot of that is going to depend on what we refer to as Le Chatelier's principle, or another term is the law of mass action, which basically states whichever one there is less of, it's going to go in that direction. And that principle is actually going to be really important. I'll actually kind of show it to you up here. It's going to be really important with this right here, and I'll get to that when we get there, and I'll kind of come back on that topic and explain why. So fructose 6-phosphate. Okay, now I'm not gonna, no wait, actually I already did. I was gonna say I wasn't gonna draw this one, but when you add the phosphate group, that is what glucose 6-phosphate is. Now fructose 6-phosphate, okay, you'll notice that it's no longer a glucose. So what's gonna happen here is we're actually gonna be going to a 5-carbon structure. Actually, well, I should say a 5-carbon ring. There's still going to be 6 carbons. There's a line there, a line there. All right, let me draw this out really quick. All right, and you're going to have your phosphate group still. Remember, we have 2 negative. Okay, so what an isomerase enzyme will do is it will actually change this structure. Oh, God, I'm really sorry, guys. My drawings are absolutely atrocious. Please understand this is the first video I've ever done. I intend for these to get better as time goes on, but hopefully I'm making some sense. What this is going to do is this structure is actually going to change by this actually opening up and bringing the carbon on the outside of the structure. And that's where this carbon comes from. This is going to open itself up. The carbon is going to come on the outside, and then it's going to close itself back in over here. And that's where you get this OH here. So then it becomes fructose 6-phosphate. Okay, now that's a different kind of sugar. This one is going to go down here. Now you'll see that this is a single line, so it can only work one way. We're going to go to fructose 1,6 bis phosphate. Some of these names can get pretty big. Bis phosphate. Okay, so this is the fructose. Now 1,6, Now I explained up here when it's on the 6th that you have the phosphate on the 6th carbon. Okay, so there's the phosphate group. It's attached to the 6th carbon. Down here it's a fructose, and the phosphate is attached to the 6th carbon. Okay, fructose because it has 5 rings, still 6 because there's still 6 carbons. Okay, 1, 2, 3, 4, 5, 6. So here, I'm actually just kind of add to it up here to explain what's going on. So bis means that there's going to be 2 phosphates, and it's going to be still on the 6th carbon, but now on the 1st carbon. So if this is the 6th carbon, then we know that this must be the 1st carbon here. Okay, so we're going to add another phosphate group. That's going to be 2 negative. Okay, so now you have 2 phosphate groups. Now it's not biphosphate, and that's an important thing to remember. Biphosphate would mean that the phosphates were on carbons that were adjoining each other. So 1, 2 biphosphate. These carbons are separated from each other. If there's a separation, you say bis. So it says fructose 1,6 bisphosphate. Again, that's because the phosphate groups are on the carbon atom number 1 and number 6, and fructose because it's a 5-carbon structure, okay, or 5-sided structure. It's 6 carbon structure, but 5-sided. If it's a 5-sided structure, it's a fructose. Okay, so over here, the enzyme that's going to catalyze that reaction is kind of a big word, phosphofructokinase. Remember, if it's a kinase, we're adding a phosphate group. We added another phosphate group to this. So this is also a kinase. Since it's this kind of a big word, we'll usually just abbreviate it as PFK for phosphofructokinase. Okay. Now, this encompasses what we call the first stage of glycolysis. The preparatory period, or what we would also call the phosphorylation period. The phosphorylation period is an important aspect of it because when glucose enters the cell through what we call a glut, there's different types of glut. That just stands for glucose, for GLU, and then transporter for the T. When glucose enters the cell through that type of protein, it is possible for the glucose to actually leave back through the protein. By adding the phosphate group to it, it makes it extremely negative, and that also makes the structure a lot larger, making it a lot more, impossible for the phosphate to actually leave back through the cell. So essentially, we're locking it into the cell. So this would be the first segment of glycolysis. Now, the next segment that we go into is what we would call the cleavage. We're going to be actually doing a separation, okay? So what this is going to do, we're going to be working with an enzyme called aldolase. Now, aldolase is going to split it. It's going to actually split the structure of fructose 1,6 bisphosphate. Now, the structures that it's going to make is going to be, if I can write this out, glyceraldehyde 3-phosphate. I'm just going to circle that there. Okay. Glyceraldehyde 3-phosphate. Or if you want, you can also put G3P. That's generally what people write. It's a lot easier. It's also the other side of the structure because, again, we're cutting it down the half of the structure here. The other half of it is going to be another big word, dihydroxyacetone phosphate. Now, we can also call this DHAP for dihydroxyacetone phosphate. Okay. So we're going to have a phosphate group on this side. We're going to have a phosphate group on this side. Each one also has 3 carbon atoms. So I'll just kind of do it like this, just so you can kind of see what's going on here. Okay, so that side you got that, but this side you have the phosphate on over here. Okay, Now, you might say, well, these are the same. Can't you just flip them around? But they actually are very different. That gets a lot more into chemistry with something we term as like cis and trans, the different way that they're facing, even though their chemical structures are completely identical. But they are different and they function differently. We've actually had medical problems in the past before we understood this. I can't remember what it was called, but there's actually a chemical that was caused a lot of birth defects, and it was meant to do something positive. Forgive me, I can't recall what it was, but because it was flipped, even though the structure was the same, it caused birth defects. And it took them quite a while to figure this out. And now, now scientists, we know after lots of studies that even though it's the same structure, just having it flipped like that, it acts completely different in the human body. Okay. Now, glyceraldehyde 3-phosphate is actually what we're going to be working with to continue through the process of glycolysis, excuse me. This one will not go through glycolysis. So this one, now I'm going to do another enzyme here. We're going to do triosphosphate. Isomerase. Again, an isomerase is a rearrangement of the structure. And since this structure and this are identical, just switched, it would make sense that the structure just needs to be kind of flipped around to make it identical to this. And that's exactly what it's going to do. This enzyme is going to switch the structure and turn it into here. Now, this one can actually go both ways. Remember what I said about the law of mass action, or also termed Le Chatelier's principle? It's going to go in the direction where there is less of. So glyceraldehyde 3-phosphate is going to continue through the process of glycolysis, which means that if it's going down through the process, there's going to be less glyceraldehyde 3-phosphate. Okay, so which means dihydroxyacetone is going to be constantly switching to glyceraldehyde 3-phosphate because there's going to be more of that going in the direction of less. Let me switch my camera here, guys. Okay, so that gives us 2 glyceraldehyde 3-phosphates. Now, for the rest of this, that was step 2, that cleavage. Okay, the rest of this is going to be the process whereby we actually obtain the products, what we're trying to get from the process of glycolysis. Understand, I'm going to be drawing this once, but everything that you're observing is actually going to be occurring twice. Let me grab another piece of paper here. It's going to be occurring twice because, again, dihydroxyacetone phosphate switched to glyceraldehyde 3-phosphate, and you already had 1 glyceraldehyde 3-phosphate. So everything here is occurring twice. So glyceraldehyde 3-phosphate, I'm just going to put this as G3P, kind of like what I was telling you guys before. This one is going to have a 2-way possible reaction. Again, it can go both ways. And it's going to change to 1,3-bis phosphoglycerate. You have to get used to these really big words. It can get tedious sometimes trying to remember these things. Okay. You know what? I actually need to come back and touch on this because I did leave out one thing that's really important here that I cannot forget this so you guys know what's going on. Okay, so from fructose 6-phosphate to fructose 1,6-bis phosphate, you're going to have another one of these reactions. Remember, I added another phosphate group. Okay, so adenosine triphosphate. Okay, phosphofructokinase is going to take the phosphate group and it's going to add it to the structure, making it fructose 1,6-bis phosphate. Okay. All right. So that happens twice in that process. Sorry about that. So this one, we're going to be working with an enzyme called glyceraldehyde. Oh, I'm going to have to come down here because I don't have room. 3-phosphate dehydrogenase. Okay. to that. Now this, oh, actually, my drawing is kind of bad here. I need to emphasize that this is occurring from glyceraldehyde 3-phosphate acts with this enzyme